Paper of the day is Optimal Column Layout for Hybrid Workloads. It's a 2019 paper. This paper shows that analytical systems relying on columnar storage can use tailored column layouts to support mixed workloads with both reads and writes. That is, using horizontal partitioning, a hybrid update policy, and ghost values. Performance can be 2 to 4 times better than that of fixed state-of-the-art designs that rely on data storage. They frame these column layout questions as an optimization problem that, given workload knowledge and performance requirements, provides an optimal physical layout for the workload at hand while remaining robust to limited workload changes. Now let's look at the experimental methodology used. For a fair comparison, Casper integrates all tested column layouts strategies. In particular, Casper has 6 distinct operation modes. First, plain column store with no data organization, column store with sorted data in the leading column, state-of-the-art update-aware column store with sorted columns and a data store for incoming updates, column store with equi-width partition data, column store with equi-width partition data and ghost values, and Casper that puts everything together. For fairness and in order to have low experimental design complexities, authors allow Casper to have as many partitions as equi-width partitioning schemes, but it has the freedom to allocate their sizes according to the optimization problem. Looking at the benchmarks, since there is currently a scarcity of benchmarks for hybrid workloads, authors develop their own benchmark and then they call it Hybrid Access Pattern, aka HAP benchmark. HAP is based on ADAPT benchmark and is composed of queries that are common in enterprise workloads, as well as transactional general update queries that are typically tested in hybrid storage engines. The HAP benchmark has 2 tables, a narrow table with 16 columns and a wide one with 160 columns. Each table contains tuples with an 8-byte integer primary key A0 and a payload of P, that is the 4-byte columns. In all of their experiments, they load 100 million tuples in database in order to report a steady state performance. Looking at the contributions, they describe the design space of column layouts containing partitioning, update policy, and a buffer space, a rich design space that supports a diverse set of workloads. They introduce 3 things: the frequency model that overlays access patterns on the data distribution, a detailed cost model for operations over partitioned columns, and an allocation scheme or mechanisms for ghost values. They formalize the column layout problem as a workload-driven binary integer optimization problem that balances read and update performance, supports service-level agreements as constraints, and offer robust performance even when the training and the actual workloads are not a perfect match. They integrate the proposed column layout strategies in their storage engine Casper and show that Casper finds the optimal data layout quickly and that it provides up to 2.3x performance improvement over state-of-the-art layouts. Looking at the PS score, overall it's a bumpy read with some super dense parts because of code and math, so it gets 9 out of 10 on readability. With 15 pages long, it scores 8 out of 10 on length. Reproducibility and repeatability shouldn't be too challenging, so it gets 9 out of 10. Industry value and learning meter is pretty high, so it gets 9 out of 10 on each. Overall PS score is 8 out of 10.